Hello and welcome to the first video lesson of the year. This lesson is going to either review for those of you who took chemistry or introduce everything you need to know about acids and bases in AP Biology. So the strict definition of an acid is anything that releases H+ in water. So this here is hydrochloric acid, okay, and we're putting it in water. And if you take a look, what happens is that the H hopped onto the water, and this became H3O+, and the chlorine was released and became Cl-. The more simple way, and the way you're going to see it, this is sort of the way you would see it in chemistry, the way you would see it sort of in bio is you would see it like this. H+ is released, and then you have the Cl- ion. Aqueous means in water, so this is hydrochloric acid in water, and it dissociates into H+ and Cl-. Okay, how strong an acid is, okay, is related, okay, to how much of the H+ is released. Okay, some of it could stay in this form, where it doesn't release the H+, where it stays H bonded to Cl, as opposed to it becoming H+ and Cl-. Now, in AP Chemistry, we dealt with this with ridiculous amounts of sort of detail. There's something called the acid dissociation constant, okay, which tells you how strong an acid is. As we scroll down, and we scroll too far. Sorry, guys. So if we look here, this is hydrochloric acid, okay. Hydrochloric acid has an extremely high Ka value because the exponent is positive. Okay, that means when it's put in water, it almost always loses all of the H, and all of the H becomes H+. You have a huge amount of H+ when you put that in water. This is acetic acid, which is more commonly known as vinegar. For those of you who, in everyday life, this is an extremely low Ka. Extremely low Ka. The exponent is negative. So when you put this in water, it only loses a little amount of H+, a tiny, tiny, tiny bit, compared to strong acids, which release a huge amount of H+ when they're placed in water. Now, on the other end of the spectrum, we have bases, and the definition that you're taught when you're in middle school is that bases are things that release OH ions in water. This is sodium hydroxide, and you see when you put it in water, it releases N+, Na+, and then OH-, and the fact that it releases OH- makes it a base. AP Chemistry does not use that definition at all, and AP Bio will not use that definition either. The more common, the more correct definition of something that is a base, something that accepts protons, or H+. Those words are used interchangeably. So remember, acids release H+, bases accept H+. So if you take a look at this reaction here, this is ammonia. Okay, ammonia is a weak base. Okay, and we put it in water, and notice what it did is it became NH4+. It took an H+ from water. So in water, you can actually rewrite like this. So in water became OH-. But this had acted like a base because it took an H+ from water and became NH4. So again, the sort of the summary or the most important part here is that acids release H+ in water. Bases accept H+ when they're put in water. Now, as you know, hopefully, water is considered neutral. Okay? And so why is water considered neutral? And we learn in AP Chem all sorts of things about how water it's not always 7, but for our purposes, okay, the pH of water is going to be 7. So why is water neutral? Well, if you look at H2O, okay, H2O, in a very, very small amounts, dissociates equally into H+ and OH-. Okay? So since you have equal amounts of H+ and equal amounts of OH-, in some way, it's acting both as an acid and a base, and therefore is neutral because it has both acidic properties, it releases H+, and both acid and both basic properties, it releases OH-. This, by the way, Marlon, just so you know, is called, we call this autoionization of water, if you want to remember from chemistry. Now, there's something called a neutralization reaction. And a neutralization reaction is when you mix equal amounts, it has to be equal amounts of a strong acid, and hydrochloric acid, HCl, is a strong acid, with equal amounts of a strong base. Which is, here's the sodium hydroxide, a strong base. And what's going to happen is this is going to release H plus here, and it's going to bind to the OH as here. Okay, so this is separated, Na is bonded to OH. Okay, this is for those of you who don't know chemistry, this is what they call a polyatomic ion. The OH stays together. And this produces H, remember the H bonds with the OH, and this is really, if we write it the normal way, water. So what's left over? Na and Cl. Okay, this is a salt. And for our purposes in AP Bio, most salts are neutral. Marlon learned it in AP Chem that is not always the case. But why is this a neutralization reaction? We took something that's a strong acid.
Good afternoon, staff. Excuse the interruption.
As there's an interruption.
At this time, for the next 10 minutes.
As I got interrupted by them testing the fire alarms, let me sort of restate what I said because I forget where I left off. So we have HCl, which is an acid, which releases H+. And then we have NaO, which acts like a base, which releases OH. And you see that produces water, which is neutral. Okay? Neither acid or base. And the salts for our purposes will also act as neutral. And so this produces, you take something that releases H+, and something that releases OH, you take an acid and a base, and you neutralize it, and you make water and salt. All neutralization reactions, as long as you react the acids in equal quantities and they're both strong, okay, will produce water, which is neutral, and a salt. Which is any ionic compound. Any ionic compound is known as a salt. So we have something to measure pH or acidity, and it's called the pH scale. And the equation is which you don't need to do, is pH is equal to the negative log of the hydrogen ion concentration. Okay, but you don't need to use that equation at all in biology. Okay, what you do need to know though is the pH ranges from 1 scale from 1 to 14 for our purposes. You can actually have negative pHs. We won't get into that. I'll put 7 in the middle. Anything between 1 and 7, or really 0 and 7, I guess, is considered an acid. Okay? And anything between 7 and 14 is considered a base. As you go this way, you get more acidic. Okay? And as you go the other way, if you want to, you get less acidic or more basic. Okay? So the lower the pH, the more acidic. Okay. The next thing, this question on the bottom, is the most important thing to understand. Okay. So let's say outside the cell looks like this. And inside the cell looks like this. And the question is, and let's say there's a surrounding barrier or some sort of circular cup, okay? And the question is, and the blue thing is the cell, okay? So the question is the pH lower or higher inside of the cell, and why? Okay. So, this is where your brain hurts a little bit. I mean, Marlon, you got this, but this is important. Where is there more H+? There's more H+ inside the cell than outside the cell. Things with more H+ have lower pHs. So more H+, okay, means lower pH. Okay? If something has less H+ than something else, okay, it has a higher pH. Okay? So acids get stronger. As acids get stronger or release more H+, this is important and I might write down. So as acids get stronger and release more H+, okay, the pH gets lower. Okay, you have no idea how hard that is sometimes. And some of you haven't even taken chemistry. You have to get that in your head. Okay, More H plus means more acidic, okay, but lower pH. Alright, so last thing that we gotta learn in this lesson is what a buffer is, and you probably won't even see this video, but this is Angelica's least favorite thing. So buffers, or compounds or substances, there are substances that resist changes in pH, or they maintain pH. And they are able to, well, they can do two things. They can accept H+, okay? And if you can accept a H+, or take it out of the environment, okay? So when you're taking the H+ and taking it away, that means you're lowering the H+. So if the buffer is accepting H+, that means it's raising the pH. Right? You're taking H+ out of the environment. Less H+ means higher pH. Okay? Buffers can also release H+. Okay? If you're releasing H+, okay, you're adding more H+ to the environment. That's making it more acidic. Okay? So you're lowering the pH. Okay. Now, so here you're going to get a lesson of an example of a buffer that works in the blood. If you remember of the word homeostasis, that means to maintain something or at a level, at an internal level, keep it the same. Okay? And you can see these double arrows mean that this reaction can go this way, producing carbon dioxide and water, or it can go this way, and this is called carbonic acid, and this is called bicarbonate ion. Okay, so you want to maintain your pH of the blood is slightly acidic. Okay, so you want to maintain it at around, it's about 5.5, around that pH. Okay, however, when you breathe and you do cellular respiration, okay, you release CO2. Okay, and CO2 reacts with the water in your blood to produce an acid, which is known as carbonic acid. Now, what you should be practicing here, by the way, is writing more than what I just write. You should also be writing what I say. This is something that's going to happen in college, so you got to learn how to do. Not only write what they write, the instructor or the teacher, or in case me, okay, writes, but also write what they say, and you can replay it if they have to. So when carbon dioxide enters the blood, it reacts with water in the blood and produces carbonic acid. Now, what's special about carbonic acid is it's a buffer, okay, because it can act both as an acid and a base, okay. If you take a look here, let's say, for example, for some reason your blood gets too acidic, okay? That means you want to get rid of the H+, or get rid of this side of the reaction. You don't want this in your blood. If the blood gets too acidic, you want to take the H+ out of the blood. So that means this reaction is going to shift this way, okay? And you're getting rid of, or reducing, or pushing the reaction all the way this way, and reducing the amount of H+. So if we add acid, okay, your blood gets too acidic, it's going to shift away from H+. Okay. Now, if we need some more room to write, let's say for some reason something happens, I don't know why, but let's say your blood gets too basic. And I scrolled too much. Your blood gets too basic, okay? So we have this system that's happening in your blood, okay? And all of a sudden your blood gets too basic. That means we want to add H+ to the environment. So that means this reaction is going to shift this way. So we're adding base to the blood, okay? And that releases H+, okay, which brings the pH down. And in this way, using carbonic acid, which can, this way it's acting like an acid, and this way it's acting like a base, can act either way to maintain the pH of your blood at roughly around 5.5-ish. Okay? So, a little sort of like test, and then this lesson is over. Here's another example of a buffer, and we'll do this quickly. Let's say they could ask a question, in a system or in a reaction, you add a base. Which way is this reaction going to shift? Okay, pause, left or right, or so. Is it going to shift this way, or is it going to shift that way? Think for a second, and then I'll give you the answer. The question was, what happens if you added base to the system? And the answer is that the reaction would shift this way, or shift to the right, because that releases H+. Remember, when you release H+, that means acid. Okay, and you just made it more basic. So releasing H plus will add more H plus and lower